Hey guys, welcome back. How do you feel about to go through basic trigonometry revision? Alright, let's do that. So before we actually got a pretty nice theoretical basis, and today we have several problems. So that's the first one, this is the second one, so you can pause the video, try to have like picture snapshots and try to work on. Okay, so the next one. Here is also find all unknowns in this triangle. Yeah, it seems to me that's it. Alright, so let's move back and just try to go through together. So I hope you did it, I hope you complete it, and let's just do and compare, have a little benchmark. Alright, so for the given triangle, express sine theta, cosine, and tangent theta through the given sides. So we're given the sides HI, IK, and HK. So we're given as like letters for each vertex, but for me it's much more convenient to use just single letters. In this case, because this is the angle theta, so that's the angle theta, I mark C here, that will be hypotenuse opposed to 90 degrees, right? That's the key place. So next one, opposite side, I put B, and for adjacent, I put A. So A logically stays for adjacent. B stays for nothing. All right. So that's, we label all the sides. Now let's go to incomplete trigonometric ratios. So first of all, just remember the basic one. So we take in the opposite side, B, and we complete B is equal to hypotenuse C times sinus of theta, sine theta. All right. So next one, let's take A. This is the adjacent side, so we take in the same manner C, but we swap sine into cosine. That's the rule I told you. If you're not sure how the ratios looks like, just go back to the video and just watch the basics and only then come here. So we swap also B into, as opposite side, into adjacent. Okay, now what if we divide B over A? B by A, so we'll get opposite to adjacent, and this by definition, so opposite to adjacent, this is by definition tangent, right? Tangent of this angle. So we've got C times sine theta, and we divided by C times cosine theta. So look what happens. C is cancelled out, and you're left with sine theta over cosine theta, which is by definition is tangent. So by the way, in previous video I never mentioned about cotangent. Actually, you're not given here, but cotangent is just the reciprocal function for tangent. So reciprocal means it's a tangent you need to flip over. So that what stays for cotangent. So if you are asked to express cotangent through the sides, it's 1 over tangent, so you simply flip it over. So you take in B over A, and remember the theory for indices, you just put the power of -1. That means your fraction is flipped over. Okay? That's for cotangent. Okay, so make sure you understand that. Okay, that was the basics. Now we are going next. So B over A, that stays for tangent. And for cotangent, for some emergency case, in case you ask to find them. So A over B, so vice versa. Okay, so next one, find all unknowns, in this case, angles and sides. Okay, so let me see. Actually, it seems to me that we can find only theta, sides we're not able to find. So that's why we need to mark 5, and that was the trick actually. So this is our just not sufficient information. Not sufficient information given. Info we are given. So that's why we need to have at least one side. So let it be 5 because A and T well known. Alright, so let's do that now. Sorry guys, that was my fault. So actually I need to put the side which is known. Okay, so now let's try to redo. So we've got the opposite side to the angle 30. That's what stays for A. So we can use A through the sine, right? Ratios through the sine. A is hypotenuse, which is 5 times sine 30, okay? So in this case, I'll give you some standard values. That's first time I'm giving to you. So sine 30 is 1/2. And cosine 30 is actually square root 3/2. So that's good because later on, later stages of your education, you need to memorize them if you're not allowed any calculators. So, and by the way, if you take 60 degrees angle, so simply if you take sine 60 and cosine 60, you just simply swap them. So square root 3 goes instead of sine 60 and 1/2 goes down. So you simply take and swap them. And this value goes here. Okay, so make sure you can memorize that. Anyway, you'll be needed soon. So next, that was stage 4A. Next, let's try to find t. So in the same manner. Oh yeah, by the way, we need to calculate. So 5 times sine 30 is going to be 5 times sine 30 is 1/2. Okay, and we finally should get the value for A, which is 2.5. Okay, that's the value for A. So 2.5. All right, let's go next. So t. So t in this case, it's adjacent side to 30 degrees. So we'll use t and the same structure, 5 times sine 30 swapped into cosine 30. And that's, we left with 5 times, so cosine 30 is square root 3/2. And that's the final answer. So 5 square root of 3 and over 2. So that's the final answer for t. If you want, you can use calculator and just calculate the value and round up to some decimal place, like to 2dp, for example. And some specific problem you'll be stated. Okay, but we need to find angle theta as well. So theta is the last unknown. What we're gonna do, we just need to add theta and 30 degrees, and hence we get 90 degrees here. Okay, or you can add with 90, you'll get 180. So the sum for all angles in the triangle. From there, theta in degrees is simply 60. All right. That's the final answer for theta. Okay, just compare in case you did something wrong. All right, so let's move next. Find OP angles ROS. All right, so let's try to do that. So first, I just mark what we know, what we don't know. So find the OP. So OP is marked with the arrow. So we need to find these lines. We also know RS is 10, so we put 10 here. QP is 25. And we also know that OS is 12. So OS, the small one, is 12. Okay. Next, we know that RS is perpendicular to OP. So we put the right angle here. And also RS and QP are parallel segments. So RS and QP are parallel. So what we can do, we can say that for two parallel lines in the second line, the angles should be corresponding, so they're the same. All right, so we put actually this one, so 90 degrees. So now everything is completed, and let's go. First, we need to find ROS. So this angle, I put theta, and let's do that. So first, to find theta, we need to consider this small triangle. So triangle ORS. It's right angle, so 90 degrees here. So we can use trigonometric ratio in order to find theta. We have the opposite side, adjacent side to the angle, so we'll use tangent. So 10/12, which is the tangent theta. All right, so we have the ratio for tangent. Let's go back to the machine. So machine works as the tangent, so that's the black box. and we've got the number as input, so 10 over 12, which is the input for our machine. So this is the number, guys, you remember, I hope. So in the end, as a result, as output, it will give you C10 degrees, all right? So we just simply taken not tangent but inverse, okay? That's the rule, and that's why you just go back to second set of operations on your smartphone and taking 10 minus 1 of the fraction 10 over 12. And it will give you theta to be 39 degrees, 0.81. So I round to 2 dp. So 2 decimal place 4 degrees. If you didn't get this value, something wrong with, first of all, if you have all the same, fair, I mean the same as I have, as I do. So you actually need to check out your calculator mode. First of all, make sure you press in 10 minus 1 button, first of all. And the second one, so make sure you have a degree mode. Because sometimes you might be given theta as like number. It means that you're using radians mode. So you need to switch to degree mode. And in this case, I hope you'll get this value in degrees. All right, so we've found theta. Now we know the angle. Okay, so we know the angle theta. And now we need to find, the second question is to find OP, the whole length. All right, so we can do actually using several approaches, but right now that's the moment how we can clarify the case about similarity, similar triangles that I showed you in the previous video where we go through the basics, how we actually use ratios, how we see that in play, and actually we considered nested triangles there. Okay, so let's see how it works. So I will use trigonometry, trigs. So trigs ratio, and now I'll consider the big triangle. So big right angle triangle. So triangle OQP, it's right angle with angle P. So what we have theta, we know that. We know the opposite side, and we want to figure out the adjacent. All right, so what we get, we're taking 25 opposite to adjacent, which is OP, that we don't know, and that will be equal to tan theta. So in this case, tan theta. In this case, of course, we can plug the value, just use calculator, again do almost the same things except for pressing the tangent. So we put angle as an input, and it should give us a number. However, look, hold on, don't do that, because you already have tangent theta as the fraction, and that means you just simply can state that it's 10 over 12 instead, okay? So hence we arrange the fractional equation. So 25 over OP is simply 10 to 12. How to resolve the ratio? Which is simply crisscross. But I want to tell you one little thing about similar triangles, because like other students might go through similar triangles. Let's compare how it works here. All right, what we have, let's see the ratio that we have. We have 25 to OP. So actually in the big triangle, 25 to the whole OP. So they mark as red sides. Okay, that's the ratio actually equals to, ratio of sides, this ratio equals to corresponding ratio of corresponding sides, so 10 to 12. So we're taking the same 10 as we start from here, and we divide it by this small side, which is 12. So we're taking 10 and we divide it by 12. So look what's happening. Actually, this is the feature of similar triangles. You remember, if they're nested, so corresponding sides, so the side in big triangle and in a small one related as 25 to 10. So you can actually write this. So corresponding side 25 to 10 related as let me see, as OP. the big one, yes, to the small one, to 12. So look, can you make this ratio to be the same as mine? If not, I'll help you. So what do you need to do? You just need to have crisscross multiplication, but you want to have OP in the bottom. So OP goes down and you swap with 10. So 10 goes up. And we'll get 25 over OP now here. And 10 goes up. Yeah, indeed. So we've got the same ratio. So what it means? That trigonometry and the outcome about relationship between opposite and adjacent side, which is tangent, and all other relationship about sides, it actually gives you the feature for proportional segments or proportional sides of the similar triangles. That actually similar triangles features in play. That's the actually outcome of their trigs ratios. Okay, trig ratios. Here we discovered a bit more, but actually in the previous video, if you watched that, we've already known that. Okay, so hope you did the same. So we've got OP. Let's just figure out OP from there. So again, how to resolve proportion. So OP goes up, 10 goes down, and 12 goes crisscross. So that's how we can do it fast. So OP on the right side, 12 goes to 25. So we've got 25 times 12 and over 10 in the bottom part. And now it's time for canceling. So 12, 25, and 10 will be cancelled. 5 here, 2 here, and 12 and 2 will be cancelled, leaving you 6 here. Okay, we completely canceled the bottom part, and 5 times 6 will give you 30. So the final answer for this problem for OP, so from there, we can get that OP is simply 30. 5 times 6. And this is the final answer. Now we know that the longest side here is 30. Alright, that how are you supposed to do? Actually, if you do without explanation, you can do it pretty fast. Okay, so just compare, try to see what's wrong in your workings, and try to one more time to redo so that you won't have any questions anymore. So let's go next. So we've got this, find all unknowns in the triangle ABC. We've got the bottom side 15. We've got this side is 10. Let's put a letter D here. And we need to find all unknowns. So we need to find theta, this small angle. And we need to find what? That's it, actually. Yeah. So in this case, we just need to find unknowns. Okay, so actually, for me, let BC is also unknown. Let's try to find that. Or actually, we can try to practice find both x and y. So y is DC. So we actually need to find also, that's the task, the problem, extra question for me. So BC and DC to find. Okay, so let's do it. So first of all, let's try to figure out. So how to find y? So y, x, and theta, all unknowns in this triangle. So that's why first, at least we need to find angle theta, okay? We know, yes, we know that this side is 10, but it doesn't give us anything, okay? But we also have the biggest side. Okay, so my proposal, let's find AD. So let's find AD. So consider triangle ABD, and let's find AD, this side. Okay, let's find this side. So AD is adjacent side. So that's why AD is simply from this triangle. We know the opposite side is 10. So adjacent side, so we can use tangent rule. So first, don't hurry up, don't try to express immediately. First, put the ratio for a tangent, and then only then try to express. Okay, so what we're gonna do, we're gonna say that we have 10 to opposite side to AD, which give us tangent 30 degrees. Okay, so go to the calculator, calculate the tangent. So I've got tangent 30 is 0.57. So if we calculate tangent on the calculator, we've got 0.577 something, 35. Okay, and from here we can express AD. So AD goes here, it swaps with 0.577. So 10 over 0.577. Or just, if you can do like in one step calculations, I advise to swap AD with the tangent 30 and then on calculator do it in one line. Okay, so we've got 10 over 17. So the result is 17. So I've got 17.32. Okay, so now we know that. Okay, we know that. We know this. So this is the value for AD. If we put 17.32, what do you actually be able to find? You can find this y side immediately, because y side is DC is the whole segment minus AD. So we can find as 15 minus what? 1732. Wow. For real? It means, so look guys, actually it means that we've got improper values for y. So what it means that actually if it's minus, so in this case we've got negative 2.32. So what it means instead of this picture, BC should go not this way, but it should go this way somehow, right? This way. Okay, I'll try to rewrite so that you understand if you found out that's negative. So however, in the real problem it's not the case, but let's try to speculate. So what actually happens? So it means that we have the right angle triangle here, which is A, let's say D and B. And actually, so that's 10, that's 30 degrees. And we found out that this side is 17.32. So it looks like your BC should go on this way, okay? BC. And that's why your actually y is this small side, which is, oh no, maybe not this side. Let me see. Yeah, if it's reflected, so angle theta becomes here. And so what actually we found? We found that if AC is 15, so AC is 15, so that one. If AC is 15, now we found this y, and y becomes 232. Now it's positive, it's okay. So you see how what negative value for side means is actually that you have side inside. So sometimes in I don't know, I've never seen this task like in this problem, so that you've got the negative side, but negative side we actually found out explanation, and that's cool. So negative means your real picture, not that. Okay. So we need to find the angle theta now. If we know, I mark what we know. We know this side, it's y, 2.32. We know this side is 10. How to find the angle theta? So what actually we need to do? We need to divide opposite side, which is y, to adjacent side 10, okay? And that gives us tangent for theta, okay? Instead of y, we put 232 that we recently found, and we divide by 10. So that's tangent theta. Okay, now guys, using calculator to figure out the reciprocal function, so inverse function for tangent. So go to the second set, tan for 232 over 10. That's your tangent. So actually, I've got theta equals to 13.07 61, so it would be 0.6 degrees. So that's the value for theta. Actually, before I also marked x. This is BC, so BC is here. So I can say that, okay, so let's try to find this side also. So I'll put the red one. So now this is also unknown. Let's put x value here. So how to figure out x? There are two ways: using Pythagoras through the right angle triangle, or again you can use relations, trigonometric ratios, in order to find x. Because this is trigonometry, let's use trigs now. So trig ratios. Okay, so let's do how to find x. This is hypotenuse. I'll use 10 and I'll use theta with the value 13.06. Alright, so I'll get 10 is adjacent side to the angle. This is adjacent side equals to hypotenuse x times cosine of the angle 1306 degrees. Alright, how to find x? From here, x is simply 10 over cosine 13.06. Okay, so in this case, let's do that. So 10 over cos of 13.06. 13.06. And what I've got hypotenuse to be 10.2065, so 27. Okay, so we found all unknowns. That was x. So from where we can find every single element. So we found that. Okay, so yeah, sorry for this picture because it wasn't drawn to scale. Actually, BC should be somewhere inverse. But anyway, as you know, it's very useful tips for you guys, so that if you have something like this, you can easily figure out with no problems. And now you know what actually, if you're given the picture not to scale, what means the negative size of the side. It means that actually you need to redraw the picture in this way. Okay, so, and the last one, find all unknowns in this picture. Okay, so let's calculate. We've got x, this side which is unknown, so let's mark A, B, C, and D. So, and first of all, what we need to find, let me see. Yeah, so let's consider the small triangle B, C, D. It's right angle triangle, so we can take opposite side and try to find adjacent. Oh, hold on. We need to find BC actually, because let me see. So I'll just go in one step forward. I'll consider triangle ABC, the biggest one. So how will we find x? In order to find x, we just simply need to know side BC, right? If we know the side BC, we can figure out. Okay, so let's try to find that. So complete the ratio for the longest side. So x, 9, and BC. So we use Pythagoras in this case. I'll give you a little shortcut how to use Pythagoras. So x squared is high because it's post 90 degrees in this big triangle. So it equals to 9 squared, one leg, and BC squared plus BC squared. So we need to define BC in order to find x. So go back here to the triangle, to the small one, B, C, D. Okay, this small triangle. So what we know, we need to find BC, but we don't know the angle. Yeah, that's the problem. Okay, so we have, so from there, if we know the angle theta, we can define BC as 4 is the opposite to the angle. So let's write. So 4 is the opposite. We'll use BC times sine theta. So BC is height for this case. Okay, so now we need to define theta angle so that we can establish the value for BC. Okay, so BC from there is simply 4 over sine theta. Okay, now we need to somehow define the value for Okay, now we need to define sine theta somehow, okay, or the angle theta itself. Let's have a look again at this triangle ABD, that small one. So consider triangle ABD. Why we're able to define this angle? Because we know that ABD is right angle. We know two sides, so we can connect or link to their angle using trigonometric, so using trigonometry, using trigonometric ratios. Okay, so 9 here, let's mark this angle as, let's say, alpha. I'll use now the Greek letters. So 9 is hypotenuse, so 4 is the opposite side. So let's complete. Opposite side is hyp times, in this case, sine of alpha. Okay, so we can figure out sine for alpha. Sine alpha is 4 over 9, or simply alpha is, let's calculate alpha. So it's going to be 4 over 9 and sine minus 1. Sine minus 1 of 4 over 9. Okay, so I've got the value 26.39 degrees. Okay, so we know the angle alpha. So 26.39. If we know the angle alpha for the big triangle, we can figure out theta. So you know that alpha and theta together, because this is also right angle, should add up to 90 degrees. Okay, two angles, 90 degrees. So from where we can find out theta in degrees. So theta in degrees is 90 minus this value. So it's 90 minus alpha, which is 26.39. And let's do it quick. So we subtract from 90. We subtract 26.39. All right, so we've got theta is about 63.61 degrees. Okay, so we found theta. We just come back to our BC. So finally we can calculate BC, which is taken 4 over sine theta, which is sine 63.61. Okay, now let's calculate. So we're taking 4 and we divide it by sine of this angle. Sine, okay. So what I've got that BC is 4.46. So check it out. So I've got 4.465, so 47. And indeed, so BC is hype, it should be more than 4. Okay, so I've got the value for that. Cool. And now, so using BC, we can calculate actually x. So from where x is square root of 9 squared is 81. So BC squared, now let's raise up power 2 squared. We've got 4.98. So that gives us, okay, let's add up with 81. So 81 plus and square root of everything. So what I've got for x, I've got 9 point, so one more time, so I've got 9.27, and that was the final value for AC. So that's the longest side. It obviously should be more than BC, both BC and AB, and this is the check, right? So your hype, your BC is hype, so it should be more than any other side in the big triangle ABC. All right, yeah, so that was pretty challenging task. Hope you do the same, or at least maybe you hired another approach. Actually, maybe you, I don't know, you found AD, you found DC and have them up. So it doesn't matter which way you go. So I show you just the consecutive ways. So when you're trying to establish, from each triangle, you're trying to pick up some equations, some ratios, and try to combine them using sort of simultaneous equations. That was the way. All right, so that was the end. Now you can go through all the solutions and check you the way you did. Okay, that's the second one. So that's the third one here, that one. And the last one, oh no, the last one. Also, we have something here. Yeah, we've got this task where we're supposed to find all unknowns. And the last one, that was a bit more challenging because it requires more equations. Okay, so guys, hope you enjoy. Don't forget to subscribe. That was Trigonometry Basic Revisions. And we'll go next. Don't worry, you'll see a lot of stuff dedicated to trigonometry and actually applied trigonometry. See you later.